So in this problem is focused about heat transfer pin problems comparing with an cylinder. In last video we only focus about the solved problem is focusing on only fins. So this is the problem is a cylinder 1 meter long and 5 centimeter diameter is placed is on atmospheric at 45 degrees Celsius. It is provided with 10 longitudinal straight fins of material having 120 watt per meter Kelvin, and the height of the material is having 0.76 mm and thickness of fin is 1.27 centimeter from the cylinder surface. The heat transfer coefficient between cylinder and atmospheric air is 17 watt per meter squared Kelvin. Calculate the heat transfer rate and temperature at the end of the fins if the surface temperature of the cylinder is 150 degree Celsius. So from this given data, the length of the cylinder is 1 meter and diameter is 5 centimeter converted into 0.05 meter, and atmospheric temperature is 45 degrees Celsius converted into Kelvin is 318 Kelvin, and number of fins is already given in the problem is 10, and thermal coefficient is 120 watt per meter Kelvin, and the thickness of the fin is 0.76 into 10 power minus 3 meter, and the length of the fin is 1.27 in 10 power minus 2 meter, and thermal coefficient height is 17 watt per meter squared Kelvin, and base temperature is 150 degrees Celsius is 423 Kelvin. To find this value and we need to find is an heat transfer rate Q and the temperature at the end of the fin. So this is a problem figure with represented with the above given data, the diameter and base temperature and atmospheric temperature and total length and number of fins 10 is represented is here. So then next we go to the solution part. We consider from this length of a section, this is a short fin comparing with the length, and in this short fin Q is equal to hb by Ka power of and Tb minus T infinity into 10 H ml. This equation from a heat transfer data book, and here is then a perimeter is a formula is 2 is the length of the cylinder and the perimeter of the cylinder is 2 meter, and area is equal to length of the cylinder and thickness of the cylinder. So finally the area of the cylinder is 0.76 into 10 power minus 3 meter squared, and m is equal to root of hb by Ka. We substitute these all values, we get it that m is root of hb by Ka, and total heat transfer is 44.3 watt. And heat transfer for 10 fins is we multiply these values into 10 is equal to 443 watt. And heat transfer of unfined surface of is the another area is focusing on the fins is equal to HA del T. So H, the area of these fins is this is the differentiation of cylinder and fin area S pi d L cylinder and 10 of thickness of the length of the fin into the temperature difference Tb minus T infinity. So substitute these all given data in this equation. We get it the Q2 of the unfined surfaces is 280.21 watt. So finally we need to we focus on the total heat transfer is we are adding the short fin heat transfer and the unfined surface heat transfer is equal to Q1 plus Q2 is equal to 723.21 watt. And finally we are need to find about temperature distribution of the short fin from the heat transfer data book is T minus T infinity by Tb minus T infinity is equal to cos h m LF minus x cos h into mlf. So when you substitute all m values is 44.3 and LF and x is from heat transfer from a given data, and m also we find and LF also from a given data, we get it the final temperature equation of the short fin is 419.94 Kelvin. So from this problem we connected within the cylinder and fins. So for example, lot of automobile engines fin surfaces are located in here. So there will be a heat transfer will be occurring to in this type of problem. So number of transfer units is given and also the short fin length is given. We using this finalized equation for temperature distribution to find it. Thank you.